Okay, so with most things in math, there are patterns with certain things. And so we're looking for patterns in special products. Let me show you what I'm talking about. All right, so if you have a situation where you have something plus something else and you are squaring that whole thing, it actually turns into something that looks like that. There's a pattern to it. Now, do you have to memorize this pattern? Absolutely not. You can simply write it out and then distribute if you want. The place where people mess up the most is people tend to forget the middle term, okay? And all they do is if they see this, they'll write a squared plus b squared and call it good. And that's wrong. You're losing your middle term because remember when you distribute, you got a squared plus ab plus ab plus b squared, right? And then you have to add your like terms together. So notice I didn't use this pattern at all. I just multiplied and I came up with the same thing that they have there. Okay, so you don't have to memorize this. When I was in school and just a young kid many years ago, we did memorize it, and I'm not sure it made me a better math student, to tell you the truth, memorizing all these things. It just kind of took up space in my file cabinet for me to understand, okay? So all I'm saying is if you understand distribution, and if you know that this right here means this right here, and you can distribute, then you can get there, okay? I would rather you understand where this comes from than memorize it, okay? So you don't ever have to memorize these special patterns. Might help you save a few minutes later on, but it's not necessary. So let's practice this, okay? Again, I'm not going to use those patterns, okay? I am just going to use distribution. So this right here means, okay? And I'm going to distribute. So y times y is y squared. Y times negative 3 is negative 3y. Negative 3 times y is negative 3y. And then negative 3 times negative 3 is positive 9. Combine your like terms. They don't cancel out because they both have the same sign in front of them. So they actually turn into that. So this right here is my final answer. Times 4, 6, and I would distribute. So 4x times 4x is 16x squared. 4x times 6 is positive 24x. 6 times 4x is the same thing. And then 6 times 6 is 36. Okay, combine your like terms. And this is it. We're done. All right, let's look at another one. So this means 2x minus 3y times 2x minus 3y. I'm going to distribute, so 2x times 2x is 4x squared. 2x times negative 3y is negative 6xy. Why did I write it xy? Well, just because I want to write it in alphabetical order. 6yx is the same thing, just so you know. So it's just easier if you get in a habit of writing things in alphabetical order, you tend to not miss your like terms. All right, so that multiplied by that, so negative 3y times 2x is negative 6. Again, I'm going to write this in alphabetical order. That way I can actually see that these are like terms. And then negative 3y times negative 3y is a positive 9y squared. Combine those like terms, and that's it. We're done. Another example. So we have 4u to the third power plus 1 times itself. Okay, so we're going to distribute again. 4u to the third power times 4u to the third power is 16u to the sixth power. Remember, add those exponents. And then 4u to the third power times 1 is positive 4u to the third power. 1 times that is the same thing. And then 1 times 1 is 1. Combine our like terms. And that's it. We're done. But there's something in math called a conjugate pair. And a conjugate pair, basically, the most basic way to tell you is you've got a term in the first and the second parenthesis that is the exact same, okay? Then you may have either another term that is a variable or a number. It doesn't really matter. Let's just call it 3 this time. And those numbers are the same. The only exception is one is a plus and one is a minus. This is called a conjugate pair. Again, I will not be asking you to define these things. I'll be using these vocabulary words, and I do expect you to know them once I teach them to you. So, might want to put this in your notes. Conjugate pair has a very special relationship whenever you distribute things out and you combine your like terms. What happens is your middle term will go away every single time. Conjugate pair, it'll come up later. I think once you get to like college level math, where a conjugate pair will help you get rid of radicals in the denominator. We're not there yet, so we don't have to worry about that now. But conjugate pairs can be very, very helpful later. Okay, so understand what a conjugate pair is. It will come up again later. But the big thing is when you multiply, your middle term goes away. All right, so first you need to be able to identify if you have a conjugate pair. Remember, this and this have to match. This and this match, but one's a plus and one's a minus, okay? So it doesn't matter which one is the plus, which one's the minus, doesn't matter the order, but watch what happens. Whenever we go through and multiply, x times x is x squared, x times positive 8 is positive 8x, negative 8 times x is negative 8x, and then negative 8 times positive 8 is negative 64. Now, let's combine our like terms. Check out what happens here. We have a plus 8x and a minus 8x. Those guys create 0. They go away. So you're left with x squared minus 64. That's it. Okay, again, I need you to be able to identify that you have a conjugate pair. So this and this match. This and this match, but one's a plus and one's a minus. That's good. Okay, so we know that we do have a conjugate pair. So we're going to go ahead and distribute. So we've got 4x squared. We've got negative 10x. We've got positive 10x. And we've got negative 25 here. These guys create 0. They go away. So I've got 4x squared minus 25. This one looks a little different, but do we have a conjugate pair? Well, let's look. So let's multiply these out and see. 9, negative 15x, positive 15x, and negative 25x squared. Looks like it. So yes, they are conjugate pairs, even though our variable didn't come first. That's it. By the way, whenever you're marking through these, do yourself a favor and make a conscious decision to look at the signs in front of the numbers. I see students all the time just mark things out and don't really pay attention. They're like, oh, well, you just mark things out all the time. But the thing is, I mark them out because this one's a minus and this one's a plus, and they're the same thing, okay? So if you have a negative 1 plus 1, those have different signs. They truly do create 0, okay? I'm not just marking it out just for the sake of marking it out. I'm marking it out because they do create 0, okay? So make sure whenever you mark things out that you're making that conscious thought to make sure that they make 0 before you mark them out. All right, do we have a conjugate pair here? That and that match? Yep. That and that match, but one's a plus and one's a minus, so yep, I think so. All right, 5m times 5m is 25m squared. 5m times 9n is positive 45mn. Negative 9n times 5n is negative 45mn. Notice I wrote that in alphabetical order. Negative 9n times positive 9n is negative 81n squared. Our like terms here are right here and right here, but look, they create 0. One's a positive 45mn, one's a negative 45mn. They do create 0. So what we're left with is 25m squared minus 81n squared. Right, again, that and that match, yep, that and that match, but one's a plus and one's a minus, so we're good. So let's multiply. CD times CD is C squared D squared. CD times 8 is a positive 8CD. Negative 8 times CD is negative 8CD. And negative 8 times positive 8 is negative 64. And our like terms are here. And look, they're the exact same, just one's a plus and one's a minus. That means they do create 0. So C squared D squared minus 64. Last one. So this and this match. Yep, this and this match, but one's a plus and one's a minus. That's great. So we're going to multiply 6u squared times 6u squared is 36u to the 4th power. Multiplying 6u squared times 11v to the 5th is positive 66u squared v to the 5th. I really have to say that carefully. All right. Now we're going to multiply negative 11 times negative 11v to the 5th times 6u squared. And we get negative 66u squared v to the 5th. And then we have to multiply negative 11v to the 5th times positive 11v to the 5th. And we get negative 121v to the 10th power. Add those exponents together. And look, this creates 0. One's a plus, one's a minus, and they're the exact same. So they do create 0. So I get 36u to the 4th minus 121v to the 10th. All right, let me know if you have any questions.